Hello, thanks for being here. My name is Shanshan from Audio Research Group, Tampere University, Finland. Today, I'm going to present our paper, Deep Neural Network-Based Low Latency Speech Separation with Asymmetric Analysis Synthesis Window Pair. I agree with you, this title is a bit long, but believe me, it is a very interesting work. This work is accomplished together with Gaurav, Arkontis, and Thomas. I'll start with a brief introduction. As we all know, for applications like hearing aids, it is very important to have the latency as low as possible, and the studies have shown that with 8 milliseconds of delay is desirable for those people who suffer from hearing loss, which also restricts us of using 8 millisecond symmetric handling window in speech separation system. And if we use 8 millisecond window length, and during this spectrogram analysis, we can see the structure is not very desirable, not very nice. And we also know that for speech signal, it is very common to use 32 millisecond window length, where you can see nice structure in the spectrogram, and also DN system can have proper pattern to analyze. However, if we use 32 millisecond window length, which will not satisfy this low latency requirement. If we want to satisfy this low latency requirement, then we have to suffer from this poor resolution spectrogram. And if we want to have better spectrogram, then it doesn't satisfy the low latency. What to do? What should we do? Luckily, asymmetric window saves the day. Let's look at how this asymmetric analysis and synthesis window look like. As shown in this figure, the solid blue line represents the asymmetric analysis window, and the red dashed line shows the synthesis window. With such window scheme, it can also achieve perfect reconstruction as how normally handling window do, but with good spectral resolution in the analysis part and with low delay in the synthesis part. With bonuses, we refer our researchers to read this original paper over here, where this originally idea comes from. Next, let's look at how this asymmetric window pair is applied in DN-based speech separation system. Given a mixture signal, we also multiply it with a windowing function, like how we normally do. And only difference is like instead of using 8 millisecond symmetric analysis window, here we use a longer 32 millisecond asymmetric analysis window. Then we apply FFT to get the spectrum, and the spectrum will go to the DN to output the mask. And during this reconstruction phase, we multiply this mask to the spectrogram, then we apply inverse FFT, and then multiply with the asymmetric 18 millisecond window instead of using the normal 18 millisecond symmetric window. And then after overlap edit, we get a clean signal back. And we evaluate this method on 2 different models and 2 different datasets. The first one is speaker-independent deep clustering model on Wall Street Journal dataset. Another one is speaker-dependent model, mask inference model on Danish Hind dataset. As shown in this figure, we evaluate this on this oracle performance compared to the baseline. We can see we have 2 dB improvement, and also improvement 1.5 dB. Improvement have also been found in the offline and online deep clustering system. And similar result can be found in this speaker-dependent model with a 2 dB increasement in the oracle performance. And for the online system, we can also observe 1.5 dB increasement. Some takeaway from this presentation. First, we propose to use asymmetric window pair for low latency DN-based speech separation, and we found out improvement of up to 1.5 dB in terms of SDR. And finally, we show that this improvement is independent of the types of model and dataset used. Thank you so much. If you find our work very interesting, please check our Git repo, where you can see how this asymmetric window pair are implemented, and also you can try out with your own samples. Thank you. Bye-bye.